Hello everyone, today we're going to be learning about pointers and references in C++. Mostly pointers, but also we're also going to be learning a bit about references, not much, but yeah. So I'm assuming you understand at least something about pointers to understand this part. Ampersand A, find the A5, if I asterisk 5, B equals to 10 here, I try to do this, it changes the value of A. This is very basic stuff. And another thing you can also do is if you want to change it like that, and the ampersand b equals to a, but here you are taking a reference. So if you check value of 10 and then you count this one, you're still going to get 10. That's the most bare minimum aspect of pointers and references that you need to understand at the beginning, at least. So, but this is just for INT, right? Let's start with arrays now. If you have an array like, say this is an array of integers which stores 5. By the way, I'm only working on stack right now, so it's very easy. I'm not working with anything on the heap. So it's also fair. Uh, the difference between stack and heap is very simple. Heap is if you allocate a memory, that memory stays on your RAM, I think, on your RAM or on any sort of memory thing on the computer, which is not deleted until you manually delete it. But stack, if I call this function for a millisecond, this is gonna be on the memory. Then after this closure is done, after this main is resolved, it's gonna pop from the memory. So that's the basic thing. Now, if you say count A, what do you assume? If it was a Java language, it'll just be 1, 2, 3, 4, 5 in a list. But since it's a C++ language, it's gonna be a pointer to the first value. So it's gonna be like, now if I dereference this, I'm gonna get 1. So if you want to point to an array, you just say int x to ptr equals to ampersand a. Do you think this is gonna work? No. It's gonna get an error. What error are you gonna get? You're gonna get cannot be initialized to use an entity of type in. Why is that? Because a is already gonna be duplicated into a pointer. A is already a memory address in a sense. I mean, it is an array. When you pass it like this, it's a memory address. So we don't need to ampersand it. And if I say asterisk ptr plus 3, which basically means the third element, and I say it's equal to 2, and if I say count asterisk ptr plus 3, it's gonna give me 6, 8, 0, 1, 2, 3. Okay, yeah, it's not the third, it's actually the fourth, my bad. So yeah, that's another bare minimum you need to understand to know about arrays and how they work with pointers. Arrays are basically, they are not exactly pointers, but they are duplicated into pointers by compiler itself. So in a sense, you can assign an array to a pointer. However, you cannot assign an array to a pointer because a pointer is not going to be duplicated in the array. Only an array is going to duplicate into a pointer. So that's basic. Now let's start with something. I think it's not like, at least I don't think this is important in like C++ because we have strings, we have literal string, we have like string string. But in C strings, we basically did something like A, B, C, and we terminate it. And if I say count C, now what do you think you're gonna get? Are you gonna get a memory address? Are you gonna get a point to the memory address? Are you gonna get A, or are you gonna get the whole string? Thing is, you're gonna get the whole string. But you see this here, right? This what is this? This is keep on changing, I think. Okay, it's not, but it's basically a garbage value. Why? Because you do not have a null terminator. If you have a null terminator, boom, that garbage value is done. This is a compiler. This is like how C++ takes strings, takes character array. So basically, string is a character array in both of the C and C++. Now, this is an array, right? So let's say we have a function, just a function now, and we want the second element to change for some reason. Okay, for some reason we want the second element to change. We have made a function. Let's see. Now see, one other thing you need to know is function. When you pass array as functions, that's no way. When you pass array as arguments into a function, that's not what it does is it makes a copy on the stack. or on the heap. No, no, on the stack itself. So that is very big, right? So if I say something like car, let's just say pointer, it's not a correct naming, but okay, for now, let's say this. So it says, well, okay, this works, and let's say the length is 4, or we could say while ptr, while asterisk ptr, and let's put that here, is not equals to a null character, and count asterisk ptr plus I. Let's say int I is 0. Oh my god, oh my god, oh my god. What forgot to put it here. Well, actually, I think the best way to do this would be, wait a minute. Yeah, okay, I am dumb. I think best way to do it here would be something like ptri. Yep, not bad. Did I call it? Why did it not work then? Why did it not work? Um, my bad. I think even this wasn't gonna work. I just had to say something like mm, while asterisk ptr plus I, and it's not JavaScript, guys. There you go. So I know that's a bad syntax. So if you want to know, just what you do is just PTRI. This is better. This is easy. Okay, and if you do this way, you don't have to have this, but you actually do. But anyways, so the thing is, what we are doing here is, see, character we know it's an array, right? Character we know it's an array, so we're passing an array as an argument. So this is also an array. But what compiler does is it does this. It says fuck your thing. This is also gonna work because an array duplicates into a pointer. However, if you want to check one thing, let's say we want to change the value of ptr equals to, which means it's the first character. Let's say it's k, and if I call, my bad, if I count it, it's gonna say k. What? Oh my bad. It's gonna say kbc because you're passing. See, in an essence, you're passing a reference, right? So that's how it works. When you say you're passing a c and you're saying this, you're passing a reference to it. You're passing a reference. So when you're passing a reference, it's not a copy. So when you do this, it actually alters the original thing in an essence. Now let's get into a bit more complicated area. Let me have a glass of water. My voice is dying. Okay. Let's say let's say instead of doing it like this, we can also do it like, you don't have to have this whole complicated mess of add an literal. You can just say this and it's still gonna work. Just be sure that you have double quotes. It's still gonna work. It's the same thing. Now, what if we are already passing a pointer though, guys? What if we're already doing this? Let's Now what do you think is gonna happen? Why am I initializing a random? Don't do this stuff. Don't initialize a variable that you're not going to use in the program. Do you think it's going to be KBC? Do you think it's going to be ABC? What do you think it's going to be? Let's see. It's going to be ABC. Sorry, the first thing is you have to say it's a const card. Okay, fuck me. It's going to say error. My bad. Why is it an error though? That doesn't make sense. Card asterisk C, function C, initializing pointer. Okay, my bad. Let's not do any of this. Because when you're passing this, now C is pointing to the whole ABC. Whereas C in the previous one was an array that had those values. So if in this case I have to do ABC, but it still won't work. It's still gonna say ABC. And the best thing you should do when you're assigning it like this is call star, because that's a good method. Because like that's a string literal in itself. When you do that, like you have to do it like this. It's a compiler thing. But why am I not getting KBC though, right? See, in the previous one, this C was, in essence, it was a reference. But why is it not working here? Because this C here is not a reference, it's a pointer. So what we have to, it's an extra step that we have to take is say ampersand. Because now we are making an alias of the pointer itself. So if we mutate the pointer, if we change the value of the pointer, then you're gonna get essentially KVC. By the way, if you also say count asterisk, my bad, asterisk PTR plus 3, which is not gonna be there, so this is 2, it's gonna have an extra C, yeah. But the reason asterisk PTR plus 1 equals to K, you cannot do this. Why can you not do this though? Why does it say there's an error? But because it's the const car, you cannot mutate a const car. It says it should be a modifiable value. But then why if I do this, I still get an error that I don't. You don't get an error no more. You now get nothing because now you are converting a string constant to a car pointer. Because the thing is, C is pointing to ABC. So you while you can mutate the string itself, you cannot mutate the you cannot mutate the insides of the string because it's not acceptable because you cannot convert a string constant to a car pointer, but you can do this ptr equals now you can mutate it. Just try it out like const. That's a good practice as I said before. And now great, let's stay. Now another interesting concept here is what if we have an array of strings? Boom, an error is popping up here. Before we talk about that error, this line is perfect. We are not doing anything. We're not changing this line in any way, shape, or form. Let's just add some strings. Escape, kick, blah blah blah. So C, as we know, is a pointer. But what is it pointing to? Now the C is not pointing to a string. Now the C is not pointing to the particular characters or the whole string or whatever you want to assume it as. Now the C is pointer to an array which has pointer that are pointing to ABC, which has sorry, let me rephrase that again. Now the C is a pointer to an array. Those array have pointer of const car type which are pointing to ABC, SHAPE, KICK. I don't know why I said it like that. So if I want to pass the value, I have to dereference this. And now let's say kick. And now what do you think it's going to What do you think this C is going to give you? This C here is not going to give you ABC, not going to give you the whole ABC shape cake or even the array. Now this C is going to give you the memory address, just like an array does. As I taught you in the beginning of this chapter, when you when you see out when you see out an array, you're going to get the memory address of the first item in that array, which is now if I dereference this, you're going to get ABC because that's the first element. But change. You are not going to get ABC. Why? You're going to get Kake because you have altered that. But if I say something like, actually, alter this, alter the PTR plus one. Why does it not work? Is dereferencing going to work? No, don't dereference it. It's not going to work. What you have to do instead is pass a different here. Pass something different. Now this is going to be ABC, but what about this? Is it going to be shade? Absolutely not. It's going to be kake because in essence, this PTR is a pointer. This PTR is one of the three pointers that points to ABC shape or kick, which you specify here. What if it's out of bound? Not an error, but it's going to be something weird. It's going to be something weird, yeah. It's out of bounds. So actually, always be sure that you're never going out of bounds because that's a big problem in these kind of questions. So yeah, that's it. What you basically need to understand is character. A string is a character array. A character that's a pointer character that's pointing to a string. You pass it, you have to pass it as a reference or an alias of ampersand. This is just an array. This is just a pointer to an array to a, which has list of pointers that points to a string literal or a const currency or Like that's how you mess these things up, because sometimes like the difference between const card and string, because people like, at least this is very effective in C. So I don't know why I'm doing this in C++, but I think this is a very essential thing you need to understand to better your knowledge on pointers or even references for that matter. Because if you understand pointers, there's nothing you cannot understand about references. I believe in C++, it's it's just lame. So yeah, I think that's the video. Yeah, and I don't think it's that. I mean, it's sure. This concept is a bit like what? Why am I pointing to a pointer? Why am I pointing to an array which is pointing to a string literal or a const card? Why am I doing that instead of just having an array of strings? But I think you need to. But I think when you brush up this part, you'll know pointers better than anything. And yeah, that's it. That's the video.